Make this a more open chat. There's a few topics I could talk about today, and maybe we can guide it depending on what people's interests are. So I lead Cohere For AI. So we are a research lab that pursues questions of fundamental machine learning progress. I'll talk today about a big project we did on multilingual, Aya, which involved 3,000 researchers across 119 countries. So fairly extensive, and maybe of interest to this group is we released both the weights as well as the largest instruction fine-tuned data set to date. It was fairly enormous, but I'm also happy to talk about other topics. I work on efficiency of models at scale, so how do we make these more accessible and smaller? So typically, releasing weights is only part of the problem. So if you release a very large weight, like 103 billion, very few people can actually run it because of hardware. So we focus a lot on efficiency. I also do a lot of work just on questions like data provenance, which I think is a topic here today. So I've been involved in several data provenance initiative projects, so happy to talk about that if there's interest, if people are aware of the work. But I wasn't sure where the interest of the room would be, so maybe I'll share like 20 minutes on Aya, and then we can open up and maybe do more free-form discussion. But just to share a bit, so Cohere For AI, and I'm guessing it's quite a glare on the screen, so I won't benchmark on the slides too much, but we're a fundamental research lab. So we're actually, probably in contrast to other industry labs like DeepMind or Anthropic, we are hybrid labs. So it means that we have a kind of industry compute, but we pair a lot cross-institutionally, and we release a lot of our work, something I'm quite proud of that we've continued to do when a lot of the field has stopped publishing. And so we share a lot of papers, and a lot of our work is cross-institutional. So some of the types of work that we work on is efficiency, it's multilingual generalization, pre-training dynamics, understanding how also our model should be used safely. So we do a lot of work around alignment of models in multilingual context, and this is very important for steering models. But today, maybe the only other thing I'll mention is we also work a lot on compute grants, so pairing with organizations to provide access to compute. And we also have a Scholars Program, which works to bring in kind of rising stars in research. So with that, I'll share a little bit about Aya, and then we can open up for maybe more dynamic discussion. So Aya was a massive effort. It was a 3-year now effort involving 3,000 researchers and then 119 countries. It was across 101 languages, and this is really kind of foolish when we embarked on it, I will admit. I think that we wanted to do something that was akin to a moonshot, as in like really when you go from one language to two, it's already complex. You end up extrapolating all the problems, tokenization, data coverage, things like understanding performance for local nuances. But then when you go to 101, it becomes a very challenging, extremely constrained setting, but because of that, everything you learn in that setting transfers to lower settings. So what I'll share a bit about is that we released, and these are the 101, and so it has not just languages that maybe receive a bit more interest and care. So we were talking over lunch about very interesting initiatives to support both French and German, but it also contains languages like Esperanto. We have also Shona, Sinhala, so these are languages from all over the world. Haitian Creole, we have Wolof. So these are important in terms of, these are often the only models that cover these languages. And when you look at this list, most people can name 20 languages, and often when you ask someone, it's the 20 languages around where they grew up. So language is very human to us. It's based on really what we see around us, but it's very hard to get to 30, and it's almost impossible to name out loud 101. And this was the technical challenge. It was really an extreme optimization problem. And that's because we had limited capacity. So we're working at a very large scale. Some of our models are 35 billion parameters. Our largest model is 103, but still, even at this scale, there's something called the curse of multilinguality, which is that as you expand the amount of coverage to get the same performance, you really have to be quite clever about how you optimize. So I'll talk a little bit about that. And so this is a cheeky slide. So we also have IA 23, which serves 23, and we do very well. So I won't tease Mistral, but we beat Mistral in our 23. So and Llama. So we're very proud. Basically, the insights that we did at 101, we transferred them to our most performant models, and we do very well. Okay, excellent. It's okay. But I enjoy the look, yes. And so this is research we did. So let me share a little bit about how we did it, and then we can open up. I like this quote: "The limits of my language mean the limits of my world." Why is multilingual modeling so challenging? I would love input. Why is it so hard?
Well, there's a lack of data problem.
Data scarcity. Excellent. Okay. Yes. What? Yes, precisely. Excellent. What else? There's no evaluations. Yes, actually, there's two problems. There's very limited evaluation, but they tend to be academic because they were developed in a different era of language, and so they don't capture how all the ways we want these models to perform, but also they all cover different languages, so it's very hard to have a comprehensive. Yes, what else? Okay, excellent. I like this. Okay, that gets a point. Yep. Go ahead. Tokenization, yes. This is a very difficult one. So typically our tokenizers, like BPE, the most commonly used ones, are developed with Latin script languages in mind, so particularly for non-Latin scripts. So if you think about Hindi, if you think about Chinese, Japanese, are very penalized by the tokenizer, and typically it means it's higher cost. It creates, you have to pay more for the same sentence because it takes more tokens to represent it. So people from certain languages end up paying more to use APIs, and it takes longer, higher latency. So it's a very excellent point. Yes, it's optimization. Anything else?
Yeah.
Okay, go for it.
The amount of training data available in non-English languages is grossly deficient.
Yes, I think this gets at Julie's point. Very nice, but I agree. Pre-training is a big problem. It's typically both a problem of quantity and quality. So, and also it's a problem of filters. So typically there's filters put in place even before, like with internet scraping, dare I say Common Crawl. There's filters meant to preserve quality, but often these penalize multilingual because some of them are very basic rule-based filters, things like that, and they don't recognize multilingual, so they just chuck it out. Yeah. Julie, did you want to say something else?
Oh, no, I have a general question.
Okay, go ahead.
Mix the languages while training, but I'm not sure if that actually is a problem or if it's just more of a question that I have.
It benefits. So cross-lingual transfer.
Yeah.
Go ahead.
Parallel data, things like that. Like, what are the different approaches to how to maximize the different languages? So how much parallel?
We'll get into it. Excellent segue. This is lovely. Okay, so we talked on some of these technical obstacles, weighting, tokenization, and then access. I think there's something we did work on this. We term it the double low resource bind. Typically, speakers of under-resourced languages also face more severe limitations in compute. So it's a double low resource bind. It means that those with the most high resource languages typically coincide with access to a lot of compute. So there are 7,000 languages in the world. Around 400 languages have more than 1 million speakers, but this is perhaps the biggest, most striking. I'll come back to this one. But I didn't include it here. Okay, but only 80% of languages have no text, which is crazy. So only 20% of languages. So why I say this is that this is actually a profoundly multimodal problem. I'll be talking about the text aspect here, but there's big, interesting implications to this. It means that audio becomes much more critical, and it's very interesting to think about. What I'll say is languages are just not treated equally by researchers. So this is a nice chart. So my mom speaks Gaelic, and Gaelic is doesn't have many speakers. So it's got 0.2 million speakers. So very small base of speakers, but it has 5,000 papers per speakers. And then you have something like Hausa, which has 70 million speakers, but only 1.5 papers per million speakers. And this is interesting because it shows it's not just a problem of representing the data, it's that the data does not represent the underlying world. And this is actually very important in terms of how we think about this and where we're trying to serve. And most languages to date have been left out. So Bloom actually was a very powerful step in this direction. It covered 46 languages, but our work was focused on expanding to 101. I'm going to skip over some of these. One thing I'll say is that the other aspect of this mismatch is that the internet doesn't reflect how we have distribution of speakers. So the internet is historically weighted, and so that means early adopters dominate the internet. So what's striking is you can have less than 10% of homes speak English, but over 50% of the internet is in English. And the same is true for Chinese, so there's a mismatch, and this is very interesting. Did someone raise their hand? Okay, good. And the compounding issue is low quality. So parallel sentences, which I think, Julie, you brought up, often it's automatically paired, and it typically is often incorrect. So it's very difficult. So I'm going to move ahead. So this is a quote by Vukosi. He's on the board of the Deep Learning Indaba. He's a professor. He's a good friend. And he says, when you are not part of the conversation, it happens to you and not with you. This is very true. It's kind of how we're building this technology. And so these are some of the things we risk, but I want to talk maybe about where we set out. I will talk about this. So typically, multilingual lack of coverage also undermines safety. So people can break guardrails very easily if they prompt in other languages. This is quite a fun paper. It says the best languages to prompt in to achieve success are Zulu and Gaelic. So it's quite interesting to think about. So I will say this. Why was this a good time to look at this? So I think when we made the decision to embark on IA, it's because several inflection points had come to the really momentum at the same time. So what were those? So why was this the right time to look at multilingual? Because I think all research endeavors are a combination. You want it to be the right timing to make progress on the task, but you also want it to be the right level of ambition. And it's very delicate to get these two right. But we felt like it was the right timing. Why would we think that? What's interesting about starting work on this 2 years ago? Courage. What breakthroughs have happened recently?
So we don't want to be under a unique, universal model from US.
That's true. So there was intrinsic motivation, but what technical building blocks were there that we felt like we could make progress on multilingual? Yeah. Yeah, that's true. There's natural momentum in the adoption of AI, so this is nice. Yeah, there's also just there's important technical breakthroughs which I think particularly benefit multilingual. So one is scaling, pre-training breakthroughs, change the multitask fine-tuning, instruction fine-tuning, preference training. I'm going to talk more about the last three because those actually particularly advantage low scarce data tasks. The first is just what's led to the current breakthroughs. So we have bigger models, which I'm grumpy about. I do a lot of work on efficiency, and I actually think our reason for bigger models is not it's a temporary. It's because we don't know how to do any better, but I think that will change. We have bigger data, but and then we have pre-training, which unlocked a lot of potential. But I will talk more about this. So we combined, I think what was an inflection point that led to instruction following is three things. It's a restructuring of data. So we did multitask training. Previously, all models were trained independently. You would have a sentiment analysis model. You would have a model for detecting the topic. You'd have another model for identifying, nationality or language based on text. this switch was to train on all tasks at once using a single model. It was a profound paradigm change for our field because it means moving to a universal, in theory, model. But why this is important is that this has important efficiency benefits. By training, you have this cross transfer between tasks, and it means you can get away with less data. The other thing is we then did two things. We changed pre-trained data into instructions and responses, and this ended up being much more efficient. It means we can train for less time on more highly structured data, and all it is a change in the data. The objective stays the same. But then with preference training, these are both much more efficient. This is particularly profound, and you may have seen examples of these type of instruction-style data sets. But this is particularly profound for data scarce problems, multilingual included. So the timing was very good for this. And typically scale helps with this. So instruction tuning benefits from having scale. There's an inflection point. So we have to go bigger, but then we can gain more from the type of data. So this is where we went with Aya. So this is what we started. We did this, and I think I'll speak for maybe 10 more minutes, and then it would be nice to open up. So we had 3,000 collaborators. These were across 119 countries, and these were researchers from all over the world. It was very interesting because everyone came with different goals. And so I will describe it as very chaotic at the beginning. And I was talking to Tom, who did big science, and I think it's very interesting because what's interesting is that you build an ecosystem as you build a technical project. And so it's both more profound because of that, but it's also lasts beyond the project. So actually, this ecosystem that we built, there's many subsequent collaborations that we've done, and this is quite special. This was the first stage of Aya, and we released both the Aya dataset and the Aya model. And we were comparing against all these models. This was the original 101, and we outperformed these models. And we released both a data set, which is human curated, both the collection, which includes all the data, so 513 million data points of instruction tunes. So this is not pre-trained, this is higher quality, and 101 languages. So this is quite profound. It covers a lot of languages. And this was the starting, really the end of like what we did, but the whole project was over a long period of time. So I'll briefly talk. This is about the types of data that we collected, and it involved many different types of data and types of tasks. We tried to get a lot of task diversity, as well as, and for comparison, so we have 513 million. The alpaca data set, which is also very well known, is 50,000. So 513 million is really, really large scale. And then we had contributions from all over, Asia, Africa, Europe, Latin America. And I think the main languages that we had were actually really Somali. So from Somalia, we had a huge community there that was really proud. And then we had Telugu, we had Sinhala, Wolof, and Hausa. So this was quite special. This was many researchers who really wanted to build a community at the same time. So it was actually very interesting. It was very research heavy of people who wanted to also kind of connect their local research communities to this global effort. It was very important to reward quality, so we tried to kind of build community in different ways. And so the other thing that we did was we tried to measure the quality. So one of the things that we looked at was the distribution of lengths, and we looked at every contribution was reviewed by someone else in the community. So this was some of the techniques that we used to try and deal with the fact that this was in many ways an ever-evolving community, and people, this is the way it was meant to be. Like, people were allowed to join and contribute and then see what they wanted to do. The only other thing I'll say about the Aya model is, maybe maybe I'll choose two things to do. So one thing is that data cleaning became important. So even though we collected all this data, we actually had scoring as well to identify the quality of it. And weighting and optimization became a bigger issue because we had so many types of data. We had to understand what did we want to weight appropriately and where. And also balancing languages became critical. And so we had indicators of quality for each data set. And we also just removed 50% of the templates for some of the existing academic data sets that were already open. We found that those were actually really poor quality. So this has also been found in the Data Provenance Initiative. Typically, released data sets are much lower quality than restricted data sets. And so it's very interesting. We ended up having to remove to improve. I'm only going to say, yeah, it's quite aggressive. Yeah. And there was an excellent point about building benchmarks. So we had to build them as we went because there was no such benchmark to evaluate 99 languages. And the other issue was the way that the languages the benchmarks that existed, they were quite rigid. They were academic in style, like measuring whether something had implicature or not. This was based on how linguistics was done, maybe 10, 15 years ago, but it doesn't capture the variety of the ways we want our models to do today. So we had to build really human kind of feedback, but also simulated large language model kind of proxies, reward scores. And so we did that as well. And what we find was we found that translation, for example, was a successful intervention. You can use translation and it improves performance, especially for very low resource. But the balancing is the most critical. So we had both template, human curated, translated, and weighting these became much more important. So what we found was the biggest gains were for middle resource, low resource. I think this is largely because they weren't recognized. I'm actually going to... maybe this is one more thing I'll say, which might be interesting, is that we found a tension. The better you get at open generations, like the type of performance we want for these models, typically the worse you get at these academic benchmarks. There's a fundamental trade-off. And this is largely because when you get better at open generation, you get more fluid, you have longer responses, which makes you a bit worse at responding with like the single response for something very rigid. So this is interesting. It means our benchmarks, we expect different things at different times. But I'm going to stop there. I think this is a nice place to open up. I will just say, so after the first IA 101, we released an IA 23, which was transferring everything we had learned from IA 23 to really the smaller set of languages and achieving state of art. So this is this is the most performant model in multilingual because this is really what we're optimizing for, is the best model in the world on these languages, and that's quite special as well. And that's also open weight, so we outperform a lot of different models. And then, if you want, you can try it. So there's a Hugging Face space where you can try it. But maybe I'll stop there. I think it's more interesting to hear questions. And how much time do we... Okay, perfect. Okay, great. Excellent. So I'll pause there. Thank you so much. This is wonderful. Thank you. Yeah. But yeah, I'm happy also, even reflections or discussion. Yeah, go ahead.
I have a question about this. So how much have you released of all the science behind it, aside from the data set and but on the training front, for example, and on the building the data set, filtering, all that code?
Yeah, we released two very extensive papers. So IA model and IA dataset paper. So the IA model paper won I'm quite proud of this. It won the best paper at ACL because, and that's a top tier conference, and it contained all the details. It was very rigorous. IA 23, we released the weights, and I think that in many ways we leverage a lot of the similar insights, and we released a technical report. And I think that we've always been trying to release all our benchmarks as well, because I think this is critical, especially since some of our benchmarks are the only ones that exist for certain languages.
So not the training, the code that you use for the training, or the code that you use for, do you have repositories for those, for the data processing?
For the data processing, so we release all the data we use for the IO 101. We don't release the code. Yeah.
Reasons for it?
It's very tied to our infrastructure, frankly. So it's not that it's we release the weights. It's not like that's probably more valuable in many ways, but it's just very tied to our particular infrastructure. Yeah. Typically, to train at scale, you need you develop a lot of internal libraries to optimize code distribution, and so it wouldn't be possible to release. Yeah. But good question.
Follow-up question. Do you think that given the industry where it's going, etc., there might be a future where those libraries might become more commoditized and there would be value in sharing the building blocks and maybe the customization, put them in a separate?
Yeah, I think so. I think there's some startups that are developing around this. Like I'm thinking of like Lamini AI. I think that's a good one, which is developing. Their main job is to accelerate workloads. I think that's and possibly one of those aspects is releasing software. But I think there's natural momentum there. The typical it's very interesting because that particular code release would actually have a limited set of users because not everyone has that much compute. So it's an interesting open source use case because actually most open source libraries, it's actually kind of a fascinating question, right? When your user base is essentially someone who owns at least 100 GPUs, but that limits who your user base is a lot, which is quite interesting. And it's interesting to think how open source serves that. Yeah, go ahead.
So it's the same way, it's an open source question, but there's some open science question.
Yep.
Depending on the field, the requirements on the application package of the experiment varies. So I understand that in your field, it's not like mandatory to associate your application package containing all that code to the reviewers, for instance.
Yeah, I think machine learning is interesting because it's gone through phases. So definitely for some conferences, you can add an anonymized link to your code. But here's the aspect that's interesting about machine learning is that the scaling has been such that even if you have access to code, you can't determine replicability. The other thing I'll say that's changed that really jeopardizes a lot of replicability is a very strict standard, but even reproducibility is jeopardized is that we can't afford multiple runs, right? When you train a 103 billion parameter model, you get a few goes, but you don't have unlimited ablations. You certainly can't report statistical significance. So the nature of the field is very different. Yeah.
I was wondering if to come back to not necessarily the curse of multilinguality, but just the question of multilinguality. If you had any takeaway points from like the advantages of having a model with so many languages versus maybe you still some advantages of it's some things that the model suffers for because of all the languages. I was wondering if you were able to do ablations for
yeah.
different data mixtures.
We did a lot of data mixtures there in the report. So basically, there's a turning point. What we did with 101 was very severe set of constraints. When we transferred that to a more limited subset, the 23, we immediately outperformed the other models because of all the when you work on a problem in extreme constraints, it forces a lot of innovation. And all those tricks we transferred down, and then we immediately got gains. So I would never recommend that 101 is the right setting if you're looking for a highly performant model. But it taught us a lot. And I think that what's interesting is that with the 23, there's certainly benefits to training languages together. Right now, our focus is actually on geo-specialized models because of the tokenization issue. So actually, this is the direction because then you get more capacity for the family of languages. And one of our goals is to train a model for European-centered languages next year, but also a separate model for Asia-centered languages. And this is actually you get both the benefits of capacity, so it's with less languages, but you get the cross-lingual transfer, which is critical. Yeah.
Sarah, can you please share with us maybe about also the organization? I mean, is it like NGO? Is it a company?
Yeah, of course. Yes, yeah. Yeah.
How do you do that?
Yeah, of course. Yeah. So we're Cohere's research lab. So Cohere is a for-profit company, and they do proprietary models. We are the dedicated research effort. But we are structured to collaborate widely. So this was one of the key criteria of how it was structured, which means that most of our collaborations are cross-institutional, and everything we do is the goal is to release. So that's why we collaborate a lot with universities. That's why IA, weights, and data have been released, and we publish so much. So this is what distinguishes us, I think, proud of. But yes, I would say Cohere is a very, I would say, big foundation model company that is both here in Paris as well as the main headquarters are in Canada and London and Toronto and SF and New York. So yeah, go ahead.
And the size of the team that is dedicated to this
My research, my research team. So our team is tasked with working on what's next, so the next generation bets. And I would say we're 30, 35 people. So actually for what we've done, working with so many collaborators, I'm quite proud. Cohere is a medium-sized company, so it's 400 people. So I think this is, but it builds foundation models and it works with companies all over the world. Yeah. Go ahead.
Hi, I'm Alec from Open Future. My native language is Polish, so
Okay.
the issue of having a good language model in Polish is very interesting for me, and I've been following also the development of various now monolingual models in Europe. I think there's like a new generation of open efforts to build models all over the place. Right?
Yeah.
Sweden, Poland, Germany, Spain. Can you say a bit more like how do you position yourselves towards them? Is your argument that we don't need these monolingual models, or should, for instance, they train on the basis of your model? I also
Yeah.
I understand you've been comparing yourself with the foundational models, but I think, do I understand correctly that, for instance, if you looked at the Polish model, you didn't even have a good benchmark to compare your IA model with the Polish one?
Maybe you can recommend. I'm sure it would be nice if. Yeah, of course. So typically.
Because that's also a big question, like, they need to build their own model.
So typically, the obstacle that people face in developing their own model is they typically try and train a primarily English model and fine-tune. This is really not. It results in a lot of problems because it's very hard to steer a model after it's been pre-trained. So in many ways, like our goal is to both control pre-training and then control fine-tuning. So most monolingual specialized models don't do pre-training, mainly because of the formidable cost and compute. And that's why, I think we compare against the models that are most widely used by people around the world for multilingual, even if they don't claim to be multilingual, which is funny. But that's because these are what are used in practice. But certainly, I think once you outperform Gemma and outperform Llama, I think I'd be curious. Do I think that monolingual models can outperform our model that is for 23 languages? Absolutely. If you have the right set of local AI experts who this is their mission, absolutely, because you can use the capacity in a clever way and you can capture local nuance about how people want their model to perform. Has that been the case? To date, typically no, because of the pre-training. It ends up narrowing who can do it. Yeah, but good question. Yeah, and maybe we're at time. Oh, okay, excellent, go ahead.
I have a question about the improvement in the translation task people. I would know how do you estimate the impact of the fact that the data is unbalanced in the distribution of the language, and if you imagine that the distribution would be perfect, how do you estimate the
So translation benchmarks, typically we measure blue. So the best translation benchmark that exists for across many languages is Flores. So this was actually put together by a group of researchers at Meta. It's actually one of the most excellent research papers I've read. It's very, they spent a long time working with translators around the world. So this is a good benchmark, and you measure basically what we call the blue score. So researchers will debate, there's critique about it, but it tends to be a good proxy for overall translation quality. So there it's balanced. In the evaluation setting, everything is balanced. So even if you've done different weighting during training, your goal is to still achieve good performance on a balanced test set after training. We don't change the test set composition to match training, because what we want to do is the best case scenario where everything's balanced. Yeah, go ahead.
I have a question that's not related to Aya, but a couple of years ago you wrote a research paper that got a lot of attention about the hardware lobby.
Yeah.
Basically says, like, correct me if I'm summarizing it wrong, but like that there's like dominant paradigms or configurations of hardware and software that then constrains what type of research is being done.
Yeah.
So since then you started running your own research lab. How much do you get to move outside of the current constraints? And so, like, what do you think are some of the more promising directions?
Yeah, thank you. That's lovely. I'm glad you enjoyed the paper. Yeah, not at all. I mean, I think most research right now is done on TPUs and GPUs, and you heavily optimize your stack. Actually, the larger your models get, the more you optimize your software stack, and the more, this is, I think, gets to the point you were talking about, is that you end up with very specific software to your particular stack, and this means you're locked in. So we have another paper we released last year, which was nice, which we showed the lack of software portability. So even if you want to have portability and you try and move from TPUs to GPUs or GPUs and back, you see large fractions of functions completely fail. So 40% of PyTorch functions fail completely when you try and move to a TPU. But for the ones that you can move, the slowdown is incredible. And what that means is it's because now software is co-developed with hardware, which means that you have more lock-in. And this is formidable. It's actually much more formidable for new hardware companies like AMD or Cerebras, or all these that have a different bent about hardware. It means that it's hard to get adoption because it's so painful trying to transfer your workload to a new type of hardware, which is very interesting. Yeah. Okay, maybe one more. Someone will tell me when I have to stop, right? Okay. Okay, good. Very good multimodality and access to multimodal data. So, for example, in Africa, for example, much more common is audio. So radio, video, and much less common. There's exceptions. I think Swahili is a very text-rich language, but I think there's differing amounts of coverage of data outside of modern social networks. So there's some social networks that have access to a lot of very rich multilingual data, like WhatsApp, because WhatsApp adoption is quite high in Africa. But in terms of formal sources that can actually be used for training, you have to go multimodal to kind of make sure these languages are represented. And I think it's also, frankly, a lack of care. Yeah, I'll be candid. Yeah, it's a lack of care. So it means that when we started Aya, no one reported what languages they covered. So none of the major models said what they covered. And I think that when we released Aya, it set a precedent for reporting. And I actually think this is what every country should demand. They should ask, what languages does your model cover that you want to make available here? Because it's important. Yeah.
So, we need to end.
Yes, perfect.
You have a full program of work this afternoon, Mere, huh? That's the point. Let's give a big applause.
Thank you.